Hi, good morning. Very good morning, all of you. Ashwin, Tajamal, Nagalakshmi, Praneeth, Lakshmi, Anjali, and two others. Good morning, everyone. Very good morning, all of you. How are you all? Everyone, how are you? Everyone, how are you? Good. So, all of you had your tea, coffee, hot water, juice, breakfast, everything? Everything is over or nothing is over? Yes, very good, very good, right? So here we'll be continuing our discussions on this, you can say, that material specifications and which one? Yeah, the material specifications and which one you can say? Right, yeah, very good morning. Material specifications and which one we'll be discussing? Materials and specifications only, right? So I am telling you again, I will not be discussing these materials in that detailed manner as that of BMCP, okay? Whichever is useful for this RCC point of view, that only I'll be discussing, right? Okay, I told you already. I'll be discussing whichever is useful RCC point of view, right? That part only we'll be discussing, you can say, right? So this is today, it is seventh part, you can say, all of you, right? Seventh part on which one? This is quick concepts and this PYQs of this RCC, right? Materials and this specifications part 7, right? So anyone having any doubts in our previous classes, previous class discussions? Anyone having any doubts anywhere? All of you? Anyone having doubts in our previous class discussions? All of you? Any doubts anywhere? Hello? Mic testing 1 2 3. Nobody is there in the class? No doubts? Okay. If no doubts, right, what we'll do is, right, we'll proceed to these discussions, you can say, right? We'll proceed to these discussions, everyone, right? If no doubts are there, okay? Shall we proceed to our discussions? Right, yeah, Shruti, good morning. Now, all of you, welcome to Unacademy. Let's crack it, right? Everybody, get ready to crack, all of you. Now, RP Civil, right? So, RP Civil is the referral code you have to use, right? Whenever you are subscribing to this plus and iconic courses, even when your friends are subscribing to this plus and iconic courses, your juniors, seniors, everybody is subscribing now, then what you need to do? You have to just go for this, right? So there is 20% off plus extra 4 months you will be having on this SSC JE and state EEG examinations. Those who are attending the YouTube, you can just click on the link there, pinned link, and so inform to all your friends, right? Those who are preparing for this state examinations, right? Help them so that they will be which one? So that they will be not missing, right? They will not be missing this, you can say, okay? Right. So this is my profile, you can say. Now, so you know, these are all the subjects I'll be taking in Unacademy already, right? These are which one? Toppers from SSC JE, right? SSC JE state AE toppers from last year. So if you want your name and your photo to be displayed in this slide next year, so you have to work hard and you have to work smart. You have to get it right. You have to solve PYQs and you have to attend every classes, maintain consistency, right? These are all the things you have to do, okay? Right, now coming to this, so we'll be having which one? This 20% off plus 4 months extra you'll be having, right? 20% off plus this 4 months extra you'll be getting. So with which one? This is 100% English content you'll be having. 20 years of this PYQs also will be solving in this plus courses, right? And this offer is valid up to which one? This tomorrow only, right? Tomorrow will be the last date for this offer, all of you, right? Tomorrow will be the last date for this offer. I don't miss this, okay? Now here this is a fee structure, right? If somebody is asking you about the fee structure now, so this is the fee structure, you can say, you will be having, okay? Now what is that? Whenever you are taking this 12 months now, you will be getting which one? This is 2 months extra, right? When you are taking 12 months, 2 months extra you will be getting. 24 months if you are taking, that 4 months extra you will be getting, right? So at this at this price, right? At this price you will be getting it, okay? So don't miss this, everyone, right? Don't miss this, all of you. Right now, this is the new batch is started, right? What is that batch? You can say that Samarth batch was started, right? Again, one batch was already started, right? Again second batch is going to start, right? Again which one? This is second batch is going to start, all of you, on which one? August 15th, right? On August 15th, that second batch is going to start, everyone, right? So don't miss this. Inform to your friends, juniors and everybody, right? In English only it will be there, right? These courses will be only there in English, okay? Right, RP Civil is the code you have to recommend and you have to use. So these are the three faculty teaching there, right? This is the course details, you can say. RCC will be taken by Amit Zeralo sir in plus courses, right? So and these are all the subjects taken by me, and the remaining subjects are taken by KP sir, you can say, right? Now you know all these things, right? Have you all applied for this AI and this SSC JE? Rahul, Ramesh, good morning. Have you all applied or not applied? If not applied, you start applying, all of you. For SSC, have you applied? Right, okay. So now these are the plus courses, right? Complete course on the surveying is going on, and these quick concepts on the this RCC is going on. And before we start, so those who are enrolling, those who are willing to enroll for this batches, we just start enrolling for this batch, all of you, right? So once enrolled, tell me everyone, this batch B, right? This batch B will be starting, right? What is it, batch B? Next batch will be starting, all of you, okay? Second batch, already batch A is running now, so batch B will be starting, all of you, right? New batch will be starting. Again the surveying will come at the end, okay, for this batch students, right? Because I'm starting surveying now, the surveying will come at the end, you can say, right? So here enrolled everyone, right? So now coming to this quick concepts, this is lecture number 7, okay? Coming to this, so what is that we have discussed yesterday? That concrete strengths we have discussed now, all of you. If you remember, right, what is that we have discussed in our yesterday's class? If you just observe that which strength will be highest, you can say everyone, that a cube strength will be highest, na? Cube strength will be higher than which one? This is cylinder strength, na? Cube strength will be higher than this cylinder strength. And after this cylinder strength, right, which one is higher? Tell me, which one is higher? Split tensile or this bending tensile is higher? Tell me, all of you. Split tensile strength will be higher or this bending tensile strength will be higher, everyone? Anybody remembered? Do you remember that yesterday we have mentioned that FT, right, that is split tension, right, split tensile strength, right, that is split tensile strength will be equal to which one? That is split tensile strength will be how much, you can say? 2 by 3 times this cracking strength, na? Yes, no? 2 by 3 times this cracking strength we have mentioned, and everyone is now. Do you remember that, all of you? So now which one? Bending strength is nothing but your FCR or this F rupture, na? Rupture strength or this fracture strength or not? So and FCR is greater than which one? This is split tensile strength, na? So FCT is the symbol we are giving for this. Greater than which one? This F direct tension, right? Is now. So is it clear, everyone? So this is your direct tension. This is your what, you can say, that is your split tensile strength, and this is your which one? This is a rupture, right? So modulus of this rupture or this which one? This bending strength, na? Modulus of this rupture or this bending strength, you can say, right? So these two are which one? These two are this compressive strengths, na? Yes or no? These two are this direct compressive strengths or not? These two are which one? This is direct compressive strengths, right? So rupture or this bending tension, you can say, right? You can call it as this rupture, or you can also call it as which one? This bending tension, if you just observe, right? Is it clear? Rupture or this bending tension, you can say, if you just observe a few, right? Right? Split tension. This is what? This is your direct tension, you can say. Is not clear of you? Split tension and this is a direct tension, right? Like this we are having, right? So everybody noted this yesterday? If not noted, you note it today. I think this one we did not add, right? Which one we did not add yesterday? That cylinder we did not add yesterday, na? So no, in yesterday's class we did not add that cylinder, right? We just add that cylindrical so F cylinder, and in the previous one, yesterday's one, you can just add, or you can write this again as you wish, right? Whichever you feel comfortable, you do that. Done, everyone? Once done, I'll try to move on to this next. So this is this is also very important at either interviews point of view or which one, this examinations point of view. Okay, done, everyone done, right? So now coming to this, right, whenever you are having this frequency distribution of this strength, if you consider, right, how this frequency distribution, this is your probability density and this is your strength, you can say, or what is it considered, this is your number of cubes and this is your strength, right? Both curves are same now. Now if you just consider it, so what is it you are having? Whenever the curve is very close to each other, right, if you just observe this curve now, this curve left side and right side parts are very close to each other now, nearby this center value now. Now what does it mean? The strength is having a very large variation or strength is varying very small value, positive and negative side. So positive side and the negative side, it is a small variation only you will be having, right? Very less variation only you will be having, right? Whenever very less variation for a mix, whenever very less variation for a mix, right, what is that? It is advantages or it is disadvantages, you can say. It is said to be having good quality or it is said to be having poor quality, everyone. It is absolutely said to be having this good quality, na? Yes or no? It is absolutely said to be having which one? This good quality, absolutely, right? Why? Why? When deviations or variations are lesser for the mix, right, so many cubes are having the strength almost near to each other, right, then automatically what is that, you can say, then automatically it is a good quality, na? Yeah, Akash Gupta, good morning. So it is, Shravan, good morning, it is good quality only, obviously, or not? Yes. Suppose if you are if it is spreading a little bit, right, if it is spreading a little bit, right, what is that, you can say, this is spreading further more, right, like this blue color one, if you just observe, right, so now the deviations are increased, you know. So whenever the deviations are increased, can you say it is a very good quality, or you can only give good quality name? Can you give very good quality name, or we cannot give very good quality? We cannot give very good quality, na? We can call only good quality, right? And if it is further deviated, if you just observe for this, right, it is deviated like this, right, this is average quality, na? So whatever it is that, whatever it is a quality, but whatever it is a quality of this mix, right, but what it is maintained, if you just observe, this shape, dumbbell shape will be maintained, na? So means it is maintaining that a normal distribution, the strength is maintaining that a normal or this standard distribution, or it is maintaining that Poisson's or beta distribution, everyone. So it is maintaining this normal distribution pattern only, no? Normal distribution, or you can also call it as which one? This is standard distribution pattern only it is maintaining, right? Normal or this is standard distribution pattern only it will be maintaining, you can say, is not? So now what happens whenever you wanted to define this characteristic strength, right, which one should be defined as this characteristic strength? If you want this to be defined as this characteristic strength, what is it, you can say? So here 95% of these cubes will be having strength greater than this, and only 5% of these cubes will be having strength lesser than this, right, like that, isn't it? So characteristic strength is defined as which one? Below which how many percent of results will fall? How many percent of these cubes will have strength lesser than that? Only 5% cubes will have strength lesser than that. 95% cubes should have strength greater than that, right? Is not? That is a characteristic strength definition, right? Is it clear, everyone? Right? Just note it and tell me. You just draw these graphs and tell me. And now whenever you are designing, right, it is better you will design for this character. Whenever you are designing the mix, it is better you design this mix for this characteristic strength, or it is better you design this strength for this mean strength, mix for this mean strength, tell me. Jahangir, Gopi, good morning. Which one is better? If you are designing for this characteristic strength, rate, what happens, you can say 50% of these results will be lesser than this value, 50% of these results will be greater than this value, right? So then can you call it as characteristic strength when 50% are lesser than this? No, no. When 50% results are lesser than this, right, can you call it as a characteristic strength? Or only how much percentage results should be lesser than that? Only 5% results should be lesser than that, na? Then only you can say that it is a characteristic strength, right? So suppose if 50%, suppose if 50% results or 50% samples are having strength lesser than this, then it is a mean strength, na, average strength, na? So it is better it is better we'll design for this FCK, or it is better we should target that FM? Our target must be FCK or our target must be FM? Tell me, all of you. Our target must be FM, na? When our target is FM, right? When our target is FM, then only we will get, then we'll get that which one, 50% results will be lesser than FM and 50% results will be higher than FM. 50% results will be lesser than FM and 50% results will be higher than FM, right? And 5% results will be lesser than FCK, right? What is our target? 5% results will be lesser than FCK. So therefore our target will be FM, right? So what is it you can say? That a target mean strength, right, for mixed design, right? So in the BMCP you will be learning, na, KP sir will be taking, right, concrete mixed design procedure and all these things. Just here whatever it is useful we are discussing that only, right? So for mixed design, what is that we are doing? For this mixed design, what is that a target mean strength, everyone? Target mean strength, that FM mean strength, right? FM means mean strength, na? Target mean strength will be greater than this FCK or lesser than FCK? Tell me, this FM value will be greater than FCK or lesser than FCK, everyone? That FM value will be obviously greater than FCK, na? So FCK plus something will come or FCK minus something will come, right? FCK plus K into, yes, right? FCK plus K into which one? This is sigma, you can say, okay? FCK plus K into that is sigma. So what is that sigma, you can say, if you just observe? Sigma is nothing but your standard deviation, na? Sigma is nothing but your standard deviation, right? Is na? K is a constant, right? K is which one? This constant, right? So you just note it and tell me. Then we'll move to the next slide and write the values of this K and other things. FCK is a characteristic compressive strength, right? We wanted to get this grade, so that 5% results will follow lesser than FCK, 95% results will have greater than FCK, right? That is our main aim, is not? To get that condition, what we need to do? We have to design the mix corresponding to which one? This FM. We have to design the mix corresponding to which one? FM. Then only we will be getting 5% results will become lesser than FCK, 95% greater than FCK, right? Like that only it will become. Done, everyone? Once it is done, tell me. What tell me? So it is following this is normal or this is standard distribution only, right? It is not following this beta distribution or this Poisson's distribution. Is not. What is the meaning of this beta or this Poisson's distribution? It is symmetrical like this, or it will be unsymmetrical in case of this beta or this Poisson's distribution. In case of this beta or Poisson's distribution, that will be unsymmetrical, na? So normal or standard distribution, it is symmetrical. Is not? Note and tell me. Good. Akshay Biswas. Note and tell me. Right. Done, everyone? Done, everyone? Shall we move forward? Right. So now what are the standard deviation values, right? According to this class 9.2.4.2, assumed standard deviations are which one? For M10 to M15, that standard deviation sigma value will be taken as which one? 3.5. So these questions are also asked. You have to be careful, right? And M20 to this M25, right? What is that standard deviation asked is which one? This standard deviation is 4. For M30 to this M50, right? What is it you can say? It is 5, right? So FM will be which one? This target mean strength, right? What is it you can say? That FM will be equal to that target mean strength, that is FCK plus which one? FCK plus which one? This K into that, K into what is it you can say, right? K into that standard deviation, right? So now what is that FM? You can say, if you just observe that FM is given as what? FCK plus 1.65 sigma we will take it, right? Why 1.65 sigma we will take it? Because for 0% definition that k will be taken as infinite, and for this 50% definition, right, k will be taken as 0, and for which one you can say, and for what you can say, and for this 5% definition, right, and for this 5% definition, and what is the meaning of this 5% definition? 5% definition, right, what is the k value taken, right, 1.65, right? So 5% definition means 5% results are assume 5% results should fall below this, then k value you have to take it as 1.65. So now you understand why it is by default we are taking 1.65 in place of k, because we are giving the characteristic strength definition as 5% results only will fall below that strength, or how many percent results will fall below that? Only 5% results will fall below that, now then you take it as 1.65. Suppose if the definition is 50% results will fall below that, when 50% results are falling below that, then if you are defining this as a characteristic strength, right, can we say characteristic strength and this mean strength both will be same, na? So when characteristic strength and this mean strength both will become same here, so do you need to Fm will be equal to that FCK, both are same, na? Yes or no? So what is the meaning of this? So this mean strength itself will be taken as which one? This F mean strength itself will be taken as your characteristic strength, right? Then in that case k value will become 0, obviously, or not? K value will become 0, right? FCK and Fm both are same. Yes, absolutely right. Yes, absolutely right. Yes, absolutely. That is why we did not take the 0. Now you understand why we did not take 0, why we have taken 5%. You may get it out, sir. Why can't we design, right? Whenever you are defining the definition of this characteristic compressive strength, sir, it is better if we design for 100% results will be greater than FCK, only 0% results will be lesser than FCK. If you wanted to design like that, right, what is that you can say? K should be infinite, na? K should be infinite, na? Now you understood why we did not take define the characteristic strength with 100% results are above this FCK only. Why we did not define? Now you understood? It's not because you have to provide infinite strength, right? Infinite strength, right? Because concrete is a material of lot of uncertainty. Whenever 100% uncertainty is there, we cannot get it. Infinite strength only possible. Infinite strength is only the solution you can have for that. Is it clear, everyone? Is it clear enough here? Right, once these are clear and noted, tell me, we'll try to move further. So M10 to M20, which grades we are talking about? Ordinary grade, right? M25 to this M60, what are the grades? Standard grade, right? M65 to this M100, what are the grades? You can say high strength concrete, na? High strength concrete, you have to be careful, right? Those are also questions asked many times, right? Today we'll be mostly finishing it off, and tomorrow we'll be doing the questions, okay, on this. Done? Once done, tell me. Clear enough you? The standard deviation values also you have to remember, right? For which grade of this concrete, how much standard deviation we have to use, and what are the key values we have to use, right? Based on the definition of this characteristic, right? Based on the for 0% definition of what? FCK, na? 0% definition of which one? This FCK, na? Right, FCK definition. Arey yaar, what happened? One sec. Arey baba, something happened. Is my screen visible? Arey yaar, for me my screen is not visible. One second, guys. Arey. Is my screen visible, everyone? Suddenly it went into sleep. What happened? Yeah, now it's okay. I think it is not having the breakfast, so that's why it went into sleep. It is saying that, "Arey yaar, sir, you did not give breakfast. You are not giving rest to me." Right? Not letting me to sleep. Early morning 8:30, you woke me up and you are taking the class. What is this? It is scolding me, it seems. Right? Done, everyone? No. So whenever you are going for this shrinkage, if you just observe it, whenever you are going for this shrinkage, right? So what is the shrinkage? You can say total shrinkage depends on the constituents of this concrete and size of this member and environmental conditions. So for a given humidity and this temperature, for a given humidity and temperature, what happens? The total shrinkage of this concrete is mostly influenced by which one? Total amount of this water present, right, at the time of mixing. To a lesser extent by which one? This is cement content, right? Cement content is influencing, but to a lesser extent, but water present will be influencing to larger extent, right? Yes, na? When more water is present, automatically what happens, everyone? More voids will be created once this water evaporates, and once this water is used for which one? More water, when more water we are using in the concrete, so after some time what happens? It will be evaporating, na? Yes, no? It will be evaporating. Once it is evaporating and some water is utilized for this which one? This reaction, hydration reaction, the voids will be created inside, na? If majority of the water is evaporating, then what will happen then? Out of this, now it is okay, everyone? Out of this entire water cement ratio we are using, only 0.25 water cement ratio will be useful for which one? This hydration reaction. Remaining everything will be to take care of this evaporation losses only. If you provide only 0.25, yeah, I'm telling, whenever you are mixing the water, what is the main purpose of this water? Water will react with the cement and it will be called as your hydration reaction. That hydration reaction, what happens? It will be only giving these components of this cement, and they will be resulting in the bonding and strength properties, bonding and then strength properties of this concrete. Isn't Vicky, good morning. So now whenever they are resulting like that, right, what will happen? We require some water. Main requirement of this water cement ratio is to take care of this hydration reaction. So for this hydration reaction, how much it is required? That 0.25 water cement ratio is only required, right? 0.25 water cement ratio is only required, right? Beyond that, it is not required. Beyond that, whatever it is providing, it is only to take care of evaporation losses, right? So 0.25 water cement ratio is utilized, and the remaining water cement ratio, water in the water cement ratio, that will evaporate now because of this heat generated in the hydration reaction and everything. Whenever this is evaporated, what happens? Automatically voids will be created, na? So whenever these voids are created, the volume of this concrete reduces definitely, na? Shrinkage effect will be created or not? More water content means that more shrinkage effect will come into picture or not? Definitely. Is that clear now? How this total shrinkage of this concrete is influenced by this water content, everyone? Is that clear all of you, these points? Yes, na? Is that clear, all of you? So whenever you are asking by default, right, which one we have to consider? Water present, water will be influencing more and cement will be influencing to less extent, right? That is what I have explained till now, na? Shruti, I have explained that only till now, na? That only I have explained till now, right? Okay, no problem. More water content is there. When more water is present, what happens? That entire water will be utilized for this hydration reaction, or that entire water will be used for hydration reaction, or some water will be evaporated. So here you will be having this cement particles. Let us say these are the cement particles, just for an example, aggregate particles and all these particles. Okay. And what happens now? This is your water content, right? This is your water content, right? This is water content, right? And whenever this water content is present, right, what is it happening? You can say. So for hydration reaction, even if you are when you are providing more water cement ratio, more water content, is it fully utilized for hydration reaction? No. No. Is it fully utilized for hydration reaction? It is not fully utilized for this hydration reaction, right? Only hydration reaction, how much it will be utilized? For hydration reaction, only that 0.25 water cement ratio will be utilized, right? Only 0.25 water cement ratio will be utilized for hydration reaction, right? Amount of water by amount of cement in the kgs, that is water cement ratio. Okay. Now remaining water cement ratio, what it will do? It will only evaporate, na? It will only evaporate, right? It will only evaporate, it will not be presented. That is for workability point of view, present in that. And after the concreting is done, slowly it will be evaporating, right? Once it is evaporating, once it evaporates, right, what happens? You can say at these places these gaps are created, na? At this place these gaps are created, na? At these water places, wherever it is evaporating, whenever these gaps or voids are created, right, they will be readjusting na. Suppose if it is having little plastic nature, they will be, the material will be readjusting and the shrinkage will occur or not. Obviously material will be readjusting and the shrinkage will occur definitely. More water is present means more water evaporates, more water evaporates means more shrinkage will happen, right? Got it? Got it, Shruti now? Yes, na? So when more water is present, more water evaporates, less water present, less water evaporates, obviously. Yes, na? Is it? So you just note it and tell me, everyone. So for a given humidity and temperature, it is depending upon which one, water present inside that and cement present inside that. But more influenced by water present, least influenced by the cement present. Okay. Note and tell me. Done, everyone? Right. Now coming to this, right, whenever you are having this, what is the influence of this duration of loading, that is strain controlled on the stress strain curve of concrete, right? So on the stress strain curve of concrete, how the duration effect will be there, if you just observe, this is your stress on x-axis and this is your strain on stress on this y-axis and strain on this x-axis, right? So this is your stress FC. Now if you just observe it, whenever you are going for this 1 minute, 1 minute loading, that entire load up to the failure we are applying in 1 minute, the curve comes like this. If it is 1 hour, like this, right? If it is 1 day, the curve comes like this. If it is 1 month, like this, 1 year, like this, right? So what happens, you can say, as the duration is increasing, right, as the strength is not changing, right, strength is not changing, but what happens, as the duration of this loading is increasing, ductility part will be increasing or not? Because this 1 hour wala curve, 1 minute wala curve will come and touch here only. So 1 hour wala curve will come and touch here, right? 1 day wala curve will come and touch here. 1 month wala curve will come and touch here. So this 1 year wala curve will come and touch here, right? Now tell me, as the duration of this loading is increasing, ductility of this concrete increases or not, everyone? If you wanted to increase the ductility, we need to increase the rate of duration, so that will be strain at the failure will be changing definitely or not? Yes, ductility will be changing, you can say, right? So failure strain increases as the duration increases. Now what is the meaning of this? Failure strain increases. Failure strain is nothing but your ductility. Now more strain at the time of failure means more ductility, less strain at the time of failure means less ductility, right? Yogendra, good morning. Failure strain, right, that is ductility increases with what? That increases with what? That increases with what? Increases with that increases with which one? This increase in duration, right? Increases with the duration of loading. Duration of this loading or time of loading, right? Is that point clear, everyone? From this left graph, from this left graph, is that point clear, everyone? Right? Once clear, note or once noted, tell me. Now this is regarding which one? This creep. If you just, this is actually the curve corresponding to this creep only. So what happens, right? This curve is loading, right? Instantaneous strain, right? This is your instantaneous strain. So what is that instantaneous strain? This is due to that load, na? This is due to that load, right? Whenever you are applying the load, immediately that strain will come into picture, na? That is instantaneous, or this which one? Short term deformation, na? Short term strain, na? So due to this external load, right? Due to this load you are having, right? Due to this load you are having. But even though you are not increasing the load, what happens? But the strains are increasing. So load is not increasing, but the strains are getting increased, right? Those strains are called with which name, all of you? Even without increasing the load, when the strains are increasing, right? What is the name of those strains? Creep strains only, no? Yes or no? Those are creep strains only, you can say, if you just observe, right? Right? Creep strains only, right? So do you remember my favorite example? All-time example? What is that, right? So in the first year, BTech, yeah, books wala example, still you remember, Gopi? Yeah. So instantaneous means immediately after the application of this load, we'll be getting some strain or some deformation. That is instantaneous strain, right? Due to that external loading, right? Due to that external loading. Immediately after the application of load, it will happen, right? Now, so in your BTech first year, what you will be having? Because we'll be preparing very hardly up to +2 or 12th class. So what is that? You did not prepare very hardly up to 12th class. So you'll be having which one? This is a textbook, rough book and everything, na? So in your engineering mechanics first year of BTech also you'll be maintaining the same thing. For every subject, one textbook, two textbooks you'll be having, right? Two textbooks you'll be having. That is the example people can understand easily, na? Is that no? Right, that's right. Two textbooks, right? One rough book, one which one? This class book, class notes you'll be having, one fair notes, right? And second year there is no concept of textbooks, only notebooks, right? So for two subjects together, one notebook, right? Front side one subject, back side another subject. Third year all subjects together, single notebook. Fourth year what happens, right? There is no notebook, single paper will take for the every class, so in the entire 1 year, is na, right? Whenever sir is looking at us, na, we'll do some action, right? Like this. Okay, sir. Okay, sir. Like that we'll see, right? We'll do over action. Na? Is that no? Rajnikant also, you can teach Rajnikant also from that. Kamal Hassan also you can teach from that over action. You can say, right? That much over action we'll do. Is not? Whenever faculty is looking at us, right? So here, but what happens, right? They will be, our parents will be allocating a almara and you will be keeping all the books in the first year there in the shelf, you can say. After that, what happens? We'll be closing this shelf in the first year, after first year is over, and second year a curtain will come. So we don't even know that there is one bookshelf, right? So third year we forget about that, right? Fourth year over, and after final year is completed, na, then all your sweet memories, happy days you will be recollecting. In that process you are just opening this ND but textbook, right? ND but engineering drawing. So there in the page number 143 you have written something, right? Yes, na? Yeah, this is my future girlfriend, right? This is my future boyfriend, right? Like that you will be writing, na, in your page number 143, just for remembering purpose. Why page number 143? You know already. So but by the time you are opening this, na, but by the time you are opening this, na, it will become like this. Why? You did not increase the load, same number of books. How many number of books when you kept in the first year? Same number of books only will be there, but it is subjected to this additional strain, right? Why? What is the reason for this additional deformation? Load is not increased, but time of this loading is increased, na? The load, sustained loading or this long term loading, because of this loading what happens, you can say these additional deformations will come, na? These additional deformations are due to the creep. Initially, immediately after you placing the books, the deformation is instantaneous deformation or this instantaneous strain, and over a long term, over a time, or if the load is kept as it is without increasing, further deformation will come. That further deformation or this further strain is called as a creep strain. Is it clear, everyone? The creep strain, all of you? Creep strain is a clear, right? What is that creep strain? Even though you are not increasing the load, the strains will increase, right? Therefore that strain is called as your creep strain, and that effect is called as your creep, right? So now what happens, this is your load due to strain due to that loads only, no, epsilon or not. After that what happens, it will be increasing as the duration increases. What happens, as the duration or time increases, what happens? So this creep strain will be increasing like this up to this point, right? It is increasing like this, it is increasing like this, it is going up to this point, right? Whenever you are unloading, na, it will be loading curve, and whenever you are unloading, na, how it will come? It will come back like this in this manner, right? Whenever you are unloading, for this portion it will be like this only, but after that what happens, right? It will come like this. Now what happens? This is instantaneous recovery, right? Immediate recovery when you start unloading, and after some time it will recover, right? So instantaneous recovery means, what is the meaning of instantaneous recovery? This whatever the instantaneous strain you are having now, how much of this instantaneous strain is recovered. This is a creep recovery means how much amount of this creep strain is recovered, right? Like that, got it? So whenever the curve is moving suddenly in the downward direction, now what you can understand, that is a recovery of this instantaneous strain. And whenever this is moving in the backward direction in the curved manner, that is your creep strain recovery, and this is the residual creep strain you are having, right? Is it clear now, this graph? Don Bosco, good morning. Is it clear everyone? Whenever you are unloading, suddenly if it is moving in the vertical direction means that is recovery, that is representing the recovery of which one? That is representing the recovery of this instantaneous strain due to loading. And whenever it is moving like this means this is representing what? Recovery of this creep strain, right? It will stop here, right? So then this is your residual creep strain, that is your recovered creep and load strain. Is not? Got it? So you just note that diagram and tell me, draw this diagram and tell me. And whatever the maximum strain you are having now, residual creep strain means even if you remove the loads also, that strain will be there as it is, right? That is residual. Because of this creep, some strain created na, Shruti, because of this creep, some strain created na, among this, so because of this load some strain created, because of this creep some strain created. When you are removing the load, what happens? Loading strain will be recovered, that straight line one, and creep strain also recovered, this one. Okay, both strains will be recovered now, but fully recovered or only partially recovered? Both the loading strain, which drawing, what I have drawn? I did not get you. How I have drawn? I did not understand your doubt. Tell me exactly. Yeah, graph. Tell me what is doubt in that graph. See, whenever you are increasing the load, na, whenever you are loading, what will happen? Immediately after the application of this load, that it will get this strain, right? Immediately after the application of this load, you will get this strain. And as the time passes, what will happen, right? As the time increases, right? As the time increases in this x-axis, that strain increases in the y-axis, and the curve will be like this, you can say. Okay, the curve will go like this. Now, suppose at this time if you are unloading, right? Let us say at this time if you are unloading, right? What will happen to this? It will unload like this first, and then it will come back like this. So what happens, you can say, so this is the amount of strain, which is strain recovered. If you just observe unloading, this is unloading the curve, this red color. If you start unloading at this location, okay, if you start unloading at this location, what will happen? So first it will move in the graph will move in the downward direction. Why? Because this is the strain recovered due to loads, right? Whatever the out of this epsilon naught, some amount of this much amount of this strain is recovered, and again it will move like this further, right? What does it mean? This is a creep strain recovered, right? So now it is not moving down, it is not coming to zero strain. What does it mean? This much amount of this creep strain will be present in that or not? This much amount of this creep strain is present in that or not? So it is left, even though we are removing the load fully, this much amount of strain will be left, right? That is your residual creep strain. Yeah, tell me, what is the difference I said? What is the difference from my statement? Tell me, Shruti. Is it different from my statement or it is same only? Kushbu, good morning. No difference, na? Is that no? No difference, right? Then, right. Statement and the diagram both are same only, na? Is that no? Statement and the diagram both are same only, na? Right. Noted and tell me. So this is ultimate creep strain, right? Ultimate creep strain epsilon u, or you can also write it as this epsilon theta. Okay, note it and tell me. So now tell me, we are mentioning that a short-term elastic modulus as 5000 root FCK, but now considering this creep effect, can we use that short-term elastic modulus every time, or depending upon the age of this concrete, we have to use that long-term elastic modulus also? depending upon the time of this loading or age of this structure, we have to use that long term elastic modulus also, na? Yes or no? So we'll be modifying, right? We'll be modifying based on which one? This is shrinkage and creep effect, na? Yes or no? So how we'll be modifying, we'll see in the next slide, but first you note it. Note and tell me. So maximum strain, whatever it comes to be, that is your ultimate creep strain, right? Why from here only we are mentioning it as a creep strain? Why not below? Below strain is created, right? This below this green line, the strain created is due to the loading, not due to the creep. Only from this point onwards that which one this creep started. So from here to highest value, that will be the ultimate creep strain, okay, not from the starting, because this is the strain due to loading, and this is only the strain due to which one? This creep, right? This is the creep created strain, this is a load created strain. Yes, no? You have to be careful. That is why we are mentioning only that point as the ultimate creep strain, okay, means only created by this creep. Note it and tell me, all of you. Done, all of you? Now if you just observe as per this, so in the options of this test data, approximate value of this total shrinkage strain, okay, right, may be taken as what? So total shrinkage strain may be taken as which one? This is 0.0003, right? So what is the total shrinkage strain? We have to take it 0.0003, right? This question also asked many times in examinations, you can say, right? 0.0003 we have to take it, right? Now considering the creep of this concrete, what is the creep coefficient? You can say ultimate creep strain, right? What is the creep coefficient, everyone? Ultimate creep strain, right? Ultimate creep strain divided by this elastic strain at the edge of this loading, right? So can we say that is epsilon naught? Elastic strain at the edge of this loading means at the time of this load, what is that strain? Elastic epsilon naught only will come into picture, na? Or you can also write it as this epsilon u ultimate creep strain divided by this epsilon e elastic strain at the edge of this loading. So this denominator will be related to the loading and the numerator will be related to this creep or not? Yes or no? Can we say this value divided by this value is the creep coefficient? So that upper wala value, ultimate creep strain value divided by this instantaneous strain value, elastic strain value, right? So this value divided by this value is the creep coefficient. Yes, now got it, everyone? Creep coefficient is what? Understood? What is the creep coefficient, everyone? Yes, now? So this value, right? This value, this is strain value, ultimate creep strain value divided by this elastic creep strain, right? This first value divided by this second value will be your creep coefficient, you can say. Yes, now? Clear? So now what is the creep coefficient for different days? You can say it is depending upon the age, na? So creep coefficient, what is it? You can say 7 days it is 2.2, that is creep coefficient theta or this phi, you can say, right? Which symbol you are habituated with, theta or phi? Creep coefficient theta or phi, right? Whichever the symbol you wanted to use, you can use, right? 28 days age it is 1.6, right? 1 year age it is 1.1, right? Yes, no? 1 year age it is 1.1. These are the creep coefficients, right? Based on your creep coefficients, based on which creep coefficients based on the age of this concrete. Why they should be based on the age of the concrete? Because the creep is time dependent or duration dependent, na, or age dependent, na. Whenever that creep is age related, it must be based on which one? This duration definitely, or age of this loading definitely, right? Yeah, Boni Santosh, correct. It is not a creep, it is a creep coefficient, okay? You have to be careful, right? It is a creep coefficient, right? See why like that you are getting, if you just observe here at the 7 days age, how much strength it will get? Tell me now. It will gain the full strength, or it will gain which one? It will gain the full strength, or it will gain only which one? This 2/3 of this strength, you can say. It will gain full strength, or it will gain only this 2/3 approximately, na, 65% of this strength only it will gain. Whenever it is gaining this 2/3 strength, but yet this 7 days age of this concrete, if you apply load, the deformations comes to be lesser or higher, loading deformations. because it has not yet achieved its full strength. Therefore, when you apply the load at the 7 days itself, the deformations comes to be lesser or higher? Tell me. Load deformations I'm talking about. Load deformations will become higher now, because it cannot resist more deformations. Why? It is not achieved full strength. So it is not achieved full strength, so the load deformations are higher. Whenever the load deformations are higher, and the creep effect also will become higher or not? Tell me now. Because it is in which one? This loose plastic condition, the creep also can be created easily or not? The creep also can be created very easily, right? Very high amount of creep will be created if you just observe, right? Is not? The very high amount of this creep will be created if you just observe, right? Isn't it? Whenever it is so very high amount of this creep is created, right? Then in that case, what happens? You can say this is 7 days. Yes, creep is related to age, and it is related to this strength also, no? Whenever the strength increases, that a creep decreases, na? Yes or no? Whenever the strength increases, that a creep decreases, na? Yes or no? Whenever the strength increases, creep decreases, right? Here at the 7 days, strength is lesser, so that creep effect will be higher or lesser? Tell me. Strength is lesser means a creep strain also can be created higher, na? But now at the 28 days, what happens? You can say 99% of this strength it will be getting, but same amount of load you apply, so that elastic deformation in the denominator it will be almost the same, but numerator what happens? You can say when the strength comes to be very much higher, it is easy to create that creep strain, or it is difficult to create creep strain in that member? Tell me. It is easy to create that creep strain, or it is difficult to create that creep strain when strength is higher? When strength is higher, it is difficult to create the strains, na? So then tell me, compared to 7 days age of loading, 28 days ultimate creep strain will be lesser, na? So this denominator may be same because of loading, but this numerator may be lesser, na? That is why the creep coefficient will become lesser. Is now numerator is same, but denominator is decreasing. When 1 year, it will be gaining furthermore higher strength, na? Furthermore higher strength means after that creep creation, at that time if you are applying loading, na, that creep effect will be very lesser, because by the time you are applying the load at 1 year, now after 1 year of construction, if you start applying load now, that creep effect it is very difficult to come. Why? Because already it is having lot of strength, more than FCK strength it is having. Then creep effect will be started immediately, or creep effect will be lesser? Creep effect will be further lesser, na? That is why this ultimate creep strain, it is very difficult to create this creep strain, because already it is having that higher strength. Is not clear everyone now? Why the creep coefficient will be decreasing as the age is increasing? Creep effect increases, okay, but creep effect increases, but at the same time the increase in the strength also will be very higher, na? But at the same time increase in the strength also will be very higher, or not? All of you, is that clear now how it is different? Is that clear everyone? Right. So you may get a doubt, sir, this is creep coefficient for 7 days, 28 days, 1 year you are having, but if you wanted to get it for another age rate, what we can get it? If you just observe how we can get it, we can get it for another age, right? Just how can you get that? You can say, how can you get that? If you just observe, you can say, how can you get that for this another age, everyone? So that theta for which one? This is some x number of these days, that is equal to theta for this x days, okay? Theta for this x days, if you wanted to get it, right? What is it? You can say 1.6, right? Suppose if it is in between, okay, we have to do the linear interpolation, okay? We'll do the linear interpolation. You can say theta x obtained by which one? This is linear interpolation. And what is that linear interpolation? Tell me. How can you get that linear interpolation? On which graph we have to get the linear interpolation, everyone? On which graph you have to get the linear interpolation, everyone? This graph. On this graph we have to get the linear interpolation, where what is that we are considering? That the creep coefficient and these values, na? Is na? The intermediate values of this creep coefficient may be obtained by interpolation, assuming that the creep coefficient decreases linearly. Creep coefficient increasing or decreases, right? Creep coefficient is decreasing linearly with what? Creep coefficient decreases linearly with a log of time in days. Right? So this is which one? This is a creep coefficient, na? This is your theta creep coefficient, theta or this phi. So what is that? You can say this is 2.2, right? So this is the 2.2 and this is which one? This 1.1 and this is 1.1. And where is that 1.6 comes? Right, this is where that 1.6 comes now. This is where that 1.6 comes. Is now. So it is 1.6 or it is a log 1.6, right? It is a log 1.6 to the base 10 now. This is also which one? This is a log 1.1 to the base 10, right? Now, so what is this value, right? Okay. Sorry. Log days, right? Log days, right? How many days you can say if you just observe how many days? This is log of 2.2 will be corresponding to how many days? 2.2 will be corresponding to this 7 days. Now this is log 7 to the base 10. So this is which one? This is which value, right? 1.6 now, and this is which value? 1.1 now. Creep coefficient is 1.1, right? 1.6 is corresponding to which one? This 28 days now. This is a log 28, you can say, right? So again, this is which one? This is a log 1 year, right? Log 1 year means a log 365, right? So what is that? You can say log to the base 10 t. What is that t? That time is in the number of days now. So now if you want that creep coefficient at which value? If you want that creep coefficient for which one? More than 7 days and lesser than 28 days, right? Whatever it is a day you require, right? You just to do the interpolation. Just for an example, right? That is your theta, 15 days if you wanted to have, right? 15 days if you wanted to have, right? What is that? You can say that is your log 15 to this base 10, and this is which one? This is theta corresponding to this 15 days. Now you do the interpolation and you can get it or not. You do the interpolation and you can get it or not. Yes. Just note it and tell me. We'll try to move forward. So done everyone. So in the shrinkages also, what are the different types of shrinkages you are having? Chemical shrinkage, autogeneous shrinkage, plastic shrinkage, drying shrinkage, carbonation shrinkage, right? Those are all the things are there, but this is not the book of RCC, okay? So that is not the part of RCC, okay? Building materials, everything will be discussed in detail, right? But here, how the shrinkage effect is considered in RCC decision, that is only important. What are the types of shrinkage? What are the factors affecting that all types of shrinkage? That is a building material part, okay? So clear everyone? Done? All of you? Now, so whenever you are having this, which one? This is stress strain curve for this concrete, now, right? This is your stress strain curve for this concrete, if you just observe, right? Why stress strain curve for concrete is required? Tell me. The stress strain curve for this concrete is required mainly to find what you can say, mainly to find which one? Mainly to find what? Mainly to find this elastic modulus, no? Mainly to find this elastic modulus of what? Concrete. Mainly to find this elastic modulus of this concrete, right? Now whenever you are considering this elastic modulus of this concrete, na, so what is that? ES will be equal to EIT, right? What is that? Initial tangent modulus, right? What is that initial tangent modulus, if you just observe? What is that initial tangent modulus, you can say? Initial tangent modulus, right? EIT, right? Directly I am writing that EIT, right? What is that initial tangent modulus, if you just observe? It is a slope of this stress strain curve at this origin, na? What is that? Can we say? It is a slope of this stress strain curve, right? Slope of which one? This is stress strain curve at which one? Slope of this stress strain curve at this origin is your initial tangent modulus, right? Now tell me that IS 456 2000 is based on which one, you can say? So now tell me, you will be getting the maximum value here or minimum value here, right? It is the maximum value, right? This is the maximum value of elastic modulus now. So you don't have any value greater than this, if you just when you are moving downward, na, curve is going down, so means the slope cannot be greater than this, right? This is the highest slope you are getting now. So maximum value of E you can obtain this one, right? Maximum value of E, right? So here what is it, you can say that IS 456 2000 has given one value now, that is based on this only, no? That IS 456 2000 has given some value now. IS 456 2000 has given some value now. That is based on this only, you can say, right? IS 456 2000 based on this only, right? So based on this means it is not exactly this, but similar to this, right? Considering this, right? Considering this, right? So IS formula IS 456 takes this as a reference, right? But is it given this exactly or no? Takes this as a reference only, right? Takes this as this a reference only, right? Takes this as a reference and obtained, and E given as, and E is given as, and E is given as which one? That Young's modulus of this concrete will be equal to the 5000 root FCK. Yes, na? 5000 root FCK. Right? Now do you remember? Because parallel to this 0.2 percentage strain we have to go for, right? That line we have to draw parallel to the initial straight line only, no? That Fy we are getting and everything. Yes, na? So initial straightness will be very importantly considered here, right? Initial straightness will be very importantly considered here, you can say. Yes, na? Right. What is the tangent modulus if you just observe? Next one is your tangent modulus. Na? What is the tangent modulus, you can say? Tangent modulus is nothing but slope of this curve at any point, right? Whatever the point you consider. If you consider a point here, na, that is which one? Tangent modulus, right? So the slope of this curve will be which one? This ET2, na, tangent modulus 2, right? Yeah, initial value where you are if you are taking the value of this E with respect to this, it will be maximum, because maximum slope you are having for this only, after that these curves are, after that these tangents are moving like this, lesser slope. So this is the one with the higher slope, means this value, initial tangent value, will be the highest value among all the Young's modulus values, right? Yes, na? Young's modulus is nothing but your slope of this curve only, obviously. So slope of the curve, when you are taking it at the starting, it will be giving highest slope, obviously, right? Whenever it is giving highest slope, so it will be the highest value, na? It will be the highest value definitely, or not? Yes, it will be the highest value, right? So noted, right? I'll be just 1 minute. Tangent modulus, right? ET. What is that ET tangent modulus, you can say? It is the slope of tangent, at which one? Any point of which one? Curve. Any point of curve. So we will be having these many values of this tangent modulus, or these are different values at different locations, right? So infinite values of tangent modulus are possible, na? Different values at which one? Different values at which one? These different locations will be having, na? Are they same or different? Different values at different locations will be having, or not everyone? So at this place one tangent, at this place one tangent, at this place also, if you just observe, this is also one tangent, ET, na? ET3. So different locations, different ET values will be getting, or not? Definitely different locations will be getting this different tangent modulus values, right? Yes, na? And now what is the next one you consider? This is your secant modulus, ES. So what is that? ES, you can say that is secant modulus. So many people will be answering that IS 456 value of this IS 456 value is based on which one? This is secant modulus. Many people will be answering that is as per the US code, not as per the Indian code. Okay, that is as per the US code, not as per the Indian code. But as per the Indian code, it is near to the initial tangent. Okay, you have to be careful. When I was teaching that IS 456 sessions also, I told this point many times. So many people will be answering that it is secant modulus. No. American codes they have taken based on this secant modulus, but Indian codes they have taken based on this initial tangent modulus. Okay, you have to be careful. Now, what is the secant modulus? It is a slope of which one? Slope of a line joining the point, joining a point and origin. So now tell me, these are also, so suppose if you consider this, na, so you are having a curve like this. At this place, if you just consider it, this is the line I am joining, right? This is the line I am drawing, right? So what is the slope of this line you are getting, right? Slope of this line you are getting it as your secant modulus at this place, right? ES1. But now suppose if I wanted to draw a line at some other location, right? If you at this point I wanted to find out, right? This is having different value, na? So no, this is having different value, that is your ES2. Yes, na? That is ES1, this is ES2, right? Now tell me, these are same values everywhere or different values at different locations, you can say. This is these secant modulus values also, which one? These are different values at different locations, na? Different values at which one? These are different locations, right? So can you rely on this also? No, we cannot rely on this, na? Different values at which one? These are different locations, right? So now what is another Young's modulus or elastic modulus given by this IS 46? Long term modulus of elasticity, right? So this is long term elastic modulus. So what is that long term elastic modulus it is given? What is that long term elastic modulus, right? It is given as EC theta. Okay, what is that EC theta? That EC theta will be equal to, so what is it, you can say EC divided by this 1 plus theta, considering the long term effect, right? What is the EC? 5000 root FCK na, 5000 root FCK divided by this 1 plus theta, right? So these are the different values of which one, this elastic modulus values we are having, right? Clear everyone? Right, so just write them after the class gets over. I'll be closing the session. Clear all of you? Anyone having any doubts? Because just 20 minutes is only left for the next class now. So yeah, shall I close? Shall I close the session, all of you? Whatever we have discussed in our today's class is clear, everyone? Is now? Right. Thank you all of you. Have a good day. Thank you everyone.